Have you ever used the graph of a function to determine a function? Let's take a look at an example about taxicabs. Here's a graph that compares the yellow cab and the blue cab. You can see that there's a couple of different things that we're looking at. We're looking at the number of miles that each cab travels and the cost for each cab ride. Now, if you look at the yellow cab first, you can see that to go 0 miles costs $2. So we can say 0 miles equals $2. So the minute someone steps in that taxi cab, they're going to automatically be charged $2. Then let's look at how much the yellow cab charges for each mile after that. If we look at 1 mile, you can go up and see that the cost is $4. 2 miles, the cost is $6. 3 miles, the cost is $8. So we can say that for every extra mile, there's an additional $2. X can be the number of miles traveled. So we start at $2 plus 2x, or $2 times the number of miles traveled, and that's going to give us the total cost. Let's write that a little neater. Total cost. Now let's look at the blue cab. If we look at the blue cab, you can see that to go 0 miles at the blue cab, you're going to pay $5 to start. That means that the minute you step in the cab, you're going to be charged $5. Now, for every mile after that on the blue cab, you're only charged $1. Because if you look at mile 1, you can travel right up here and see that you're only being charged $6. So plus $1 times the number of miles is going to give you the total cost in the blue cab. So you could say that we have two functions represented. We have the yellow cab function over here in red, and we have the blue cab over here in blue. And we can say that the cost is a function of the number of miles traveled in both cases. Now, let's take the information that we've gathered and write a function rule. We're going to write a function rule for the yellow cab and a function rule for the blue cab. For the yellow cab, let's put it in red as we did on the other page. We can say that the function of x, which is our total cost, is equal to 2x plus 2. Now you may be thinking, where did that come from? Well, 2x is the $2 that's charged for every mile traveled. X is the number of miles, and the 2 is the cost just when you step in the cab. Remember, we talked about that there was a base cost of $2 before that cab had gone any miles at all. So this function will help us to determine the total cost if you're riding in the yellow cab. Now let's think about the blue cab. The function of x in the blue cab is a result of x plus 5. Remember, we could put a 1 here. That's the fee charged per mile, $1. Or you could write it without the 1, just with an x. 5 is the cost that is charged before the taxi even moves. There's a base fee of $5. So x again here is the number of miles traveled. And you can see by looking at the graph that if the blue cab goes 3 miles, the total cost is $8. And if the yellow cab goes 3 miles, the cost is $8. Let's look at the graph again and check and make sure that this is accurate. Here's our graph. Let's look at 8 miles. You can see, let's look at $8 and 3 miles. If we're going 3 miles, the total cost on both cabs is the same. It is $8. Working in this way shows us how we can use the graph of a function and function rules to solve problems.